In this video, we're looking at finding the area of a sector of a circle. Now, a sector of a circle is basically bound by two radii of the circle. So these are our radii here, JK and JL, and it's the portion between the radii and that intersected arc. You can think of a sector as kind of like a slice of pizza. We're just finding the area of a portion of this circle here, all right? The formula that we use is area equals x times pi r squared divided by 360. X is the degree of the arc, and of course r is the radius. And you probably recognize that pi r squared, that is the formula for area of a circle. And so instead of finding the entire area of a circle, we want to just find a portion, which is called a sector. All right. So we're just going to take the information that we have and plug it in here. So area equals the degree of the arc. The degree of the arc is 84. So we multiply 84 times pi r squared. R is the radius. So that's 3 squared divided by 360. And from that point, we're just simplifying. 84 times 9 pi divided by 360. And I'm going to write my answer in terms of pi. All right, so I'm just going to leave pi there and not multiply it through. So 8 times 9 is, or 84 times 9 is 756. We divide that by 360. All right, and of course, if you wanted to write your answer as a decimal, you would just multiply this by pi. I want to reduce this fraction. 36, both of them may be divisible by 36. Let's see. 756 divided by 36 is 21, so let's see. So that's 21, and we know that 360 divided by 36 is, of course, 10. All right. Can I reduce 21 over 10? No, I cannot. So my final answer is 21 pi. And we found the area of a sector of this circle. All right, so we have another problem here, and we have a large sector that we want to find the area of. We're not given the degree of the arc, but we can find it by using this 42-degree central angle right here. So now remember that there are 360 degrees in this circle. So we're simply going to subtract 360 minus 42. And I think that is 318, right? And so the measure of this angle would be 318. Therefore, the measure of this major arc will also be 318. Okay, so I just subtracted from 360. So now I have the degree of the arc, and I can just plug it in. We're given that YZ equals 9, so that's our radius. And let's just plug it in. Area equals X. X is 318, the degree of the arc, times pi. R is my radius. So 9 squared divided by 360. 318 times 9 squared. 9 squared is 81. All right. So 318 times 81. What did I do with my calculator? I dropped it. So 318 times 81. 25,758 divided by 360 pi. So I'm writing it in terms of pi. I always want to make sure that I write the answer in lowest terms. So basically just reducing the fraction. So 360, that could be divisible by 36. I don't think this would be divisible by 36 or 12. If I try 12, no, that doesn't work. It gives me a decimal. Let's try 6. So 25,758 divided by 6 is 4,293. 360 divided by 6 is, of course, 60. I always double check. And I don't think they have anything else in common. So I've reduced it. And I just bring my pi down. So I just found the area of this sector of this large portion of the circle. All right, so the last problem I want to show you here has several sectors. All right, and so I want to find the area of all the sectors added together. So the information I'm given here is I have this 62-degree angle right here. So that tells me that this arc is also 62 degrees. And since I have these congruence marks, that tells me that the other arcs here are also 62 degrees. All right. So now we could find the length or the combined length of these arcs by simply doing 360 minus 62 times 3. Because if I find the length, if I multiply these by 3, right, and subtract it from 360, it'll give me these arcs that are left. All right, so 360 minus 62 times 3, that is 174. Or you could just put 360 minus 62 minus 62 minus 62. Doesn't matter, you end up with 174. So that is the sum of all of these arcs right here that we need. So we can use that 174 degrees and plug it into our formula. So area equals 174, because again, these are all the arcs that we are left over that we want to find the area of. Okay, times pi. My radius here is 12. 12 squared divided by 360. 174 times 144, because 12 squared is 144. It's 360 pi. Okay. 174 times 144 is 25,056 divided by 360. I'm going to try dividing by 72. Let's see. And it does go in there evenly, so 348. 360 divided by 72 is 5. 5 doesn't have any more factors other than 1, so I've reduced that fraction. And I just bring down my pi. And we have inches, so that would be inches squared for the area of the sectors of this circle.